This video covers report period 2, week 5 homework in pre-calc. The first thing the homework reviews this week is composition of functions. We can see in example 1 that we're being asked to find f of g of x. I always want to begin with the outside function, in this case f of x. F of x is 5x minus 2. When I compose f of g of x, I'm replacing the x in 5x minus 2 with the function g of x. So when I rewrite f of x, instead of x, I'll replace the input with x plus 7. Notice that I've rewritten the original function, f of x, exactly as it was originally, but I've replaced the input value, x, with g of x, which is x plus 7. Once I've set this up, all I need to do is simplify. 5 times x is 5x, plus 35 minus 2. After I've distributed, I can combine like terms, and I end up with 5x plus 33. In question 2, we're being asked to work with the same functions, but this time to find g of f of x. Because the outside function has changed to g of x, I'll start by writing down x plus 7, which of course is g of x. Just like in question 1, I replaced x with g of x, the new input. Here, I'm replacing x with f of x, 5x minus 2. 5x minus 2 is now the input, then I'm adding 7. I'll combine like terms, negative 2 and 7, for a final answer of 5x plus 5. Those are always the steps you'll follow to compose functions, where you start with the outside function and replace the input value x with the inside function. On Tuesday night, you're being asked to review piecewise functions. To write piecewise functions of a graph, we need to first determine the equation of each piece. I can see that the red line on this graph has a rise of 10 and a run of 5, which tells me that the slope is 10 over 5, or 2. The equation of this red line is therefore y equals 2x, because 2 is the slope. I don't need to add a y-intercept, because I can see that the y-intercept is 0. The blue piece of this graph is simply y equals 20. Because it's a flat horizontal line, there is no slope, and the output is simply 20, regardless of the input value. Once I've determined the equations for each piece of the graph, I'm going to set up my piecewise function. My first piece of the function is f of x equals 2x. And I know that f of x is equal to 2x when the input value of the function is between 0 and 7. I can see that 7 is the place where my function changes from 2x to y equals 20. And so I write my equation like so. 2x if x is greater than 0 and less than 7. The second piece of my function is y equals 20, the same thing as f of x equals 20. And I can see from my graph that that's the case between, this time, 7 and 10. And so I'll write my domain as x is greater than 7 and x is less than 10. On Wednesday night's homework, you're being asked to write the inverse function from each equation. Let's recall our steps to write inverse functions. First, I rewrite the function with y instead of in function notation, because it's going to make it easier for me to flip the x and y values, which is step 2. Notice that all I've done here is take my original function, x minus 3 over 7, and flipped the input and the output values. Once I've flipped the input and the output values, I'm simply solving for y. I'm going to move this over here so I have more space. X equals y minus 3 over 7. I'll multiply both sides by 7. And I end up with 7x equals y minus 3. Then I'll add 3 to both sides. And I end up with 7x plus 3. Instead of writing equals y, I can go back to function notation and say the inverse of f of x is 7x plus 3. One place where we've been getting a little bit stuck in class is when we have to work with square and square root. Remember, if I have a function like x squared plus 4, I start in the exact same way, where I simply flip x and y. You want to think of an exponent as being even more powerful than multiplication or division, which means that we need to undo addition and subtraction before we can undo the exponent. And I end up with x minus 4 equals y squared. Now I'm ready to undo the exponent with my square root symbol, and that square root symbol will cancel out with the exponent, which leaves me with the square root of x minus 4, and instead of y, I'll write f negative 1 of x, better said as the inverse of f of x. This is my final answer. Remember, x squared can be undone by a square root, and the square root of x can be undone by a squared. Finally, you've got Thursday night's homework, where you're being asked to find the inverse function of each function that's graphed below. Here, you have 2 steps. The first thing you need to do is determine the function that's being graphed by finding the slope and the y-intercept. I'll pick a trickier one where we have a y-intercept, like this third question here. I can see that the slope of this graph is 1 over 3. That's my rise over run, so I have 1/3 x, and my y-intercept is 5. So my equation is 1/3 x plus 5 equals y. To find the inverse equation, I'm going to follow my regular steps, where I flip x and y, then solve for x by subtracting 5 from both sides. 1/3 y equals x minus 5. And to reverse times 1/3, I'll multiply both sides by 3. But don't forget that you're multiplying the entire right side by 3, which gives you y equals 3x minus 15. Recall that if I'm multiplying by a fraction, like times 1/3, I can undo times 1/3 by multiplying times 3 over 1. They flip. I know that multiplying by the reciprocal fraction, where the numerator and denominator simply change places, will bring me to 1, or cancel out. That's it for this week's homework helper. If you need extra support, please make sure to see me in office hours.